Hello, in this lecture we will find the area of the green triangle. In the drawing we have triangle ABC that is an equilateral triangle. That means that an equilateral triangle, all the angles are equal to each other, all the angles equals to 60 degrees, and also all the sides of an equilateral triangle are equal to each other. So actually we can write down that side AB of the triangle equals to side AC and equals to side BC. AB equals to BC equals to AC. Okay? In an equilateral triangle, all the sides are equal to each other, so AB equals to AC equals to BC, but we know that the size of BD is 2 units, and the size of DC, it is given us in the question, equals to 4 units. So actually the side BC equals to 4 plus 2 units equals to 6 units. So actually all the sides of this equilateral triangle equals to 6 units. So if we define AF as X, then BF equals to AF, so BF will be also X. So we know that AF plus BF equals to AB. AF plus BF equals to AB. And AB equals to 6 units. Okay. AF plus BF equals to AB, and AB equals to 6 units. But AF equals to X and BF also equals to X. So actually we can write that 2X equals to 6 units. Okay, AF is X and BF is X, so AF plus BF is 2X. So 2X equals to 6 units. We will divide this equality by 2 and we will get that X equals to 3 units. Okay, X equals to 3 units, so actually the value of BF is 3 units, and the value of AF is also 3 units. Okay, and we will define FD as A. FD, line segment FD will be equal to A, and line segment DE will be equal to B according to our definition. And then we will find the value of A by using the law of cosines. According to the law of cosines, if you have a triangle with sides of A, B, and C, this side is A, this side of the triangle is B, and this side is C, and we know that this angle is theta, then according to the law of cosines, c squared equals to a squared plus b squared minus 2 times ab cosinus theta. Okay, this is the formula of the law of cosines, that the value of c squared equals to a squared plus b squared minus 2 times ab cosinus theta. Okay, so we actually can implement the law of cosines in our circle, because here fd square will be equal to bf square plus bd square minus 2 times bf bd bf times bd cosinus 60 degrees. Okay, we implemented the law of cosines in triangle BFD. Okay, in triangle BFD we implemented the law of cosines. According to the law of cosines, fd square equals to bf square plus bd square minus 2 times bf times bd times cosinus 60 degrees. We know that cosinus 60 degrees is 1 over 2, so fd square will be equal to bf square. bf equals to 3, so 3 square is 9, plus bd square. bd equals to 2 units, so 2 square is 4, minus 2 times bf is 3 and bd is 2, and cosinus 60 degrees is 1 over 2, so in total we got that fd square equals to 9 plus 4 minus 2 times 2 over 2. Here we can cancel 2 because we have 2 in the numerator and in the denominator of this expression, so 2 is cancelled. So in total we will get that fd square equals to 9 plus 4 is 13, equals to 13 minus 2 times 3 is 6. So in total we got that fd square equals to 13 minus 6, but fd equals to a, so we can substitute fd by a. So a square equals to 13 minus 6 is 7. We got that a square equals to 7. So if we can take a root out of this equality, and we will get that A equals to the root of 7 units. Okay, A equals to the root of 7 units, so we can write here that A equals to the root of 7 units. Okay, and in the next step we will define angle BFD. This angle is theta, and we will define angle BDF as alpha, and we will also define angle CDE as gamma, and we will define angle DEC as beta. Angle DEC equals to beta, this angle, and we know that in any triangle in the world, the sum of its angles equals to 180 degrees, so it is also correct in triangle FBD. In triangle FBD, the sum of its angles equals to 180 degrees, that is to say 60 degrees plus alpha plus theta, equals to 180 degrees. And the same thing is true about triangle DEC. This triangle, the sum of its angles equals to 180 degrees. So our first equation is 60 degrees plus alpha plus theta equals to 180 degrees. That is to say, the sum of the angles in triangle FBD equals to 180 degrees. And we will also create the second equation that states that the sum of the angles in this triangle DEC equals to 180 degrees. That is to say 60 degrees plus gamma plus beta equals to 180 degrees. Okay, so our second equation states that 60 degrees plus gamma plus beta equals to 180 degrees. That is to say, the sum of the angles in triangle DEC equals to 180 degrees. Okay, the sum of the angles in triangle DEC equals to 180 degrees. In the next step, we will add together equation 1 with equation 2. Okay, we will add equation 1 to equation 2. We'll get equation number 3. Actually, 60 plus 60 is 120 degrees. 60 degrees plus 60 degrees equals to 180 degrees. And we have here alpha plus theta plus gamma plus beta. Okay, we added equation number 1 to equation number 2. And in the other side of the equation, we have 180 degrees plus 180 degrees equals to 360 degrees. Okay, in total we got that 180 degrees plus alpha plus theta plus gamma plus beta equals to 360 degrees. We'll subtract 180 degrees from equation number 3. We will get that alpha plus theta plus gamma plus beta equals to 360 degrees minus 180 minus 120 degrees equals to 240 degrees. Okay, we got that alpha plus theta plus gamma plus beta equals to 240 degrees. Now we will have the fourth equation that states that the sum of the angles in on a straight line, on the upper side of a straight line, at any point on a straight line, the sum of the angles on the upper side equals to 180 degrees. So if we focus on point D here, you can say that the sum of the angles in the upper side of side BC will be equal to 180 degrees. That is to say, alpha plus 90 degrees plus gamma will be equal to 180 degrees. Again, the sum of the angles on the upper side of a straight line equals to 180 degrees, and it is also true that the sum of the angles on the bottom side of a straight line equals to 180 degrees. So the sum of the angles around point D on the upper side of side BC equals to 180 degrees. That is to say, alpha plus 90 degrees plus gamma equals to 180 degrees. Okay, so we have this fourth equation that states that alpha plus 90 degrees plus gamma equals to 180 degrees. We will subtract 90 degrees from the fourth equation, and we will get that alpha plus gamma equals to 90 degrees. According to our fourth equation, alpha plus gamma equals to 90 degrees. Okay, but we have in our third equation also alpha plus gamma. Here we have in the third equation alpha plus gamma, so you actually can substitute alpha plus gamma by 90 degrees because alpha plus gamma equals to 90 degrees. So we'll substitute alpha plus gamma in the third equation by 90 degrees because alpha plus gamma equals to 90 degrees. Okay, and we will get that theta plus beta plus 90 degrees equals to 240 degrees. Okay, we substituted alpha plus gamma by 90 degrees in the third equation, and we got that theta plus beta plus 90 degrees equals to 240 degrees. Now we will subtract from the third equation 90 degrees, and we will get that theta plus beta equals to 150 degrees. Okay? We got from the third equation that theta plus beta equals to 150 degrees. So we can subtract from the third equation theta, and we will get that beta equals to 150 degrees minus theta. Okay, we subtracted theta from the third equation, and we got that beta equals to 150 degrees minus theta. Okay, in the next step we will find the value of sinus theta and cosinus theta by implementing the law of sines on triangle BFD. Okay, actually, what is the law of sines? Actually, if we have triangle with sides A, B, and C, this side is A, this side is B, and this side is C. This angle is theta, this angle is beta, and this angle is alpha. According to the law of sines, the relationship in any triangle in the world between their sides to their angles is the following relationship: that A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay, it is true for any triangle in the world. That is the relationship between the angles to the sides of any triangle. A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay, so we can implement the law of sines in triangle BFD. In triangle BFD, FD over sinus 60 degrees will be equal to 2 over sinus theta, or to BD over sinus theta. Okay, so according to the law of sines in triangle BFD, FD over sinus 60 degrees equals to BD over sinus theta. Okay, but we know that FD equals to the root of 7. Okay, so we can substitute FD by the root of 7. And we also know that BD equals to 2 units. BD equals to, it is given us in the question that BD equals to 2 units, so we can substitute BD by 2. So we substituted FD by root 7 and BD by 2, and we got that root 7 over sinus 60 equals to 2 over sinus theta. Now sinus 60 degrees equals to root of 3 over 2. Okay, so we have root of 7 over 1 over root of 3 over 2 equals to 2 over sinus theta. Okay, so root of 7 over root of 3 over 2, because sinus 60 equals to root of 3 over 2 equals to 2 over sinus theta. Here we can do the simple arithmetic that actually 2 times root 7 over root 3 equals to 2 over sinus theta. Okay, we got that 2 times root 7 over root 3 equals to 2 over sinus theta. Here we have 2 in the numerator of this side of the equation, and we have 2 on the numerator of the other side of the equation, so we can cancel 2. And what we left is root of 7 over root of 3 equals to sinus theta equals to 1 over sinus theta. Okay, we will do the simple arithmetic here, and we will get that sinus theta equals to the root of 3 over root of 7. Okay, we got that the root sinus theta equals to the root of 3 over root of 7. In the next step, we will calculate the value of cosinus theta by implementing the trigonometric identity that states that sinus theta squared plus cosinus theta squared equals to 1. We have this trigonometric identity that states that sinus theta squared plus cosinus theta squared, sinus theta squared plus cosinus theta squared equals to 1. From here we can derive that cosinus theta squared equals to 1 minus sinus theta squared. From this equality we subtracted sinus theta squared, so we got that cosinus theta squared equals to 1 minus sinus theta squared. Okay, and from this equality we can take a root from this equality. We will get that cosinus theta equals to 1 minus sinus theta squared, all in the root, because we took a root from this equality and we got that cosinus theta equals to 1 minus sinus theta squared. So we know that sinus theta equals, we found out that sinus theta equals to the root of 3 over root 7. So if sinus theta equals to the root of 3 over root 7, then sinus theta squared will be equal to 3 over 7 units. So we can substitute sinus theta squared by 3 over 7, because sinus theta squared equals to 3 over 7. So we'll get that cosinus theta equals to the root of 1 minus 3 over 7. Okay, we substituted sinus theta squared by 3 over 7, and we got here that cosinus theta equals to 1 minus 3 over 7. Cosinus theta equals to the root of 1 minus 3 over 7. 1 minus 3 over 7 is 4 over 7, so I write it down. So we got that cosinus theta equals to the root of 4 over 7. The root of 4 is 2, so I will write it down. So we get that cosinus theta equals to the 2 over root of 7. Okay, so cosinus theta equals to the 2 over root 7, while we have already found that sinus theta equals to the root of 3 over root 7. Okay, we already found that sinus theta equals to the root of 3 over root 7. Okay, so we found out the values of cosinus theta and sinus theta. Okay, Actually, we have already found out that beta equals to 150 degrees minus theta. Okay, we have already found out that by solving the three equations, we found out that beta equals to 150 degrees minus theta. So we can write down that sinus beta equals to sinus 150 degrees minus theta. Okay, if beta equals to 150 degrees minus theta, then sinus beta equals to sinus 150 degrees minus theta. Okay, and we'll solve this equality by the trigonometric identity that states we'll calculate the value of sinus 150 degrees minus theta according to the trigonometric identity that states that the value of sinus alpha minus beta, the value of sinus alpha minus beta equals to sinus alpha cosinus beta minus sinus beta cosinus alpha. Okay, actually we have this trigonometric identity that states that sinus alpha minus beta equals to sinus alpha times cosinus beta minus sinus beta times cosinus alpha. Okay, so we can write down that the value of sinus beta equals to sinus 150 degrees minus theta and we will develop this expression sinus 150 degrees minus theta according to the trigonometric identity of sinus alpha minus beta, when alpha equals to 150 degrees and beta equals to theta. So according to the trigonometric identity of sinus alpha minus beta, sinus of 150 degrees minus theta will be equal to sinus 150 degrees times cosinus theta minus sinus theta cosinus of 150 degrees. Okay, so we actually developed the expression of sinus 150 degrees minus theta according to the trigonometric identity of sinus alpha minus beta that equals to sinus alpha cosinus beta minus sinus beta cosinus alpha. Okay, and we got this expression that sinus 150 degrees times cosinus theta equals to sinus theta times cosinus 150 degrees. Okay, so the value of sinus 150 degrees equals to 1/2. So we got here 1/2 times cosinus theta minus sinus theta cosinus 150 degrees. The value of cosinus of 150 degrees is actually minus root of 3/2. Okay, so in total we got that all equals to 1/2 times cosinus theta minus sinus theta times root of 3/2. Now we have the values of cosinus theta and sinus theta, so we can substitute cosinus theta by the value of cosinus theta, and we substitute sinus theta by the value of sinus theta. We know that cosinus theta equals to 2/7 to 2/7, so in total we get 1/2 times 2/7. Minus times minus is plus, and we have here sinus theta. Sinus theta equals to root of 3/7. Times root of 3/2. Okay, so after we put the value of sinus theta and cosinus theta in this expression, we got that 1/2 times 2/7 plus root of 3/7 times root of 3/2 equals to this, to sinus beta. So we have 2 in the numerator of this expression and 2 in the denominator of this expression, so 2 is cancelled, and root of 3 times root of 3 is 3, so we can write down the new expression. We got actually that 1/7 plus 1/7 times 3/2. Okay, we got that 1/7 plus 1/7 times 3/2. We can take a common factor of 1/7 out of this expression, and we will get that 1/7 is the common factor. Inside the brackets we will have 1 plus 3/2. Okay, we took a common factor of 1/7 out of this expression. We got in the brackets that we have here 1/7. In the brackets we have 1 plus 3/2. 1 plus 3/2 is 5/2. So I write it down. Actually we got that sinus beta equals to 1/7 times 5/2. Okay, So the value of sinus beta is 5 over root of 7 times 2. Okay? In the next step, we will implement the law of sines in triangle DEC in order to find out the value of B. According to the law of sines, B over 60 degrees over sinus 60 degrees, B over sinus 60 degrees equals to 4 over sinus beta. Okay, we actually implemented the law of sines in triangle DEC. According to the law of sines in triangle DEC, B over sinus 60 degrees equals to 4 over sinus beta. Okay, in triangle DBC, B over sinus 60 degrees equals to 4 over sinus beta. But we know the value of sinus beta. We have already found out the value of sinus beta, so we can put in this expression the value of sinus beta, and actually sinus 60 degrees equals to root of 3 over 2. Okay, so we put the data inside this expression, equality, P over 1 over root of 3 over 2 equals to 4 over 1 over 5 over 2 times root of 7. So we put the value of sinus beta, we substituted sinus beta by the value of sinus beta here, and sinus 60 degrees equals to the root of 3 over 2. Here we will do the simple arithmetic, this expression, and we will find out that 2b over root of 3 equals to 2 times 4 times root of 7 over 5. Okay, in total we got that 2 times b over root of 3 equals to 2 times 4 times root of 7 over 5. Here we have 2 in the numerator of this side of the equation, we have 2 in the numerator on the other side of the equation, so we can cancel 2, and what left after the cancellation of 2 is actually that b equals to 4 times root of 3 times root of 7 over 5. Okay, so we got the value of b. b equals to 4 times root of 3 times root of 7 over 5. Okay, and we have already found out that the value of a is root of 7, So the area of the green triangle, the area of any triangle is the base of the triangle times the height of the base over 2. So the area of triangle, the green triangle FED will be equal to B times A over 2. Okay, the area of the green triangle is A times B over 2. A times B over 2, and A equals to the root of 7, and B equals to 4 times root of 3 over root of 7 over 5. So actually the area of the green triangle is root of 7 times 4 times root of 3 times root of 7. So root of 7 times root of 7 is 7. So I have made some mistake here. So in total we got that the area of the triangle equals to 7 times root of 3 times 4 over 5. So the area of a triangle equals to A times B over 2. So I actually forgot to divide this equality by 2. So after I divide this equality by 2, we get that the area of a triangle, of the green triangle, will be equal to 2 times 7 times root of 3 over 5 square units, or the area of the triangle equals to 14 times root of 3 over 5 square units, or the area. So the area of the triangle equals to 14 times root of 3 over 5 square units. So the area of the triangle in terms of numbers equals to 4.85 square units. Okay, so the area of the green triangle equals to 4.85 square units. Okay, now I will summarize the lecture. Actually, we wanted to find out the area of the green triangle, and we have an triangle ABC is an equilateral triangle. That means that all the sides of this triangle ABC are equal to each other, and all the angles inside triangle ABC equals to 60 degrees, and we know that the size of line segment BD is 2 units, the size of line segment DC is 4 units, and also that AF equals to BF. So actually, as I've already said, that the sides, all the sides of an equilateral triangle are equal to each other. Okay, so actually side BC of the equilateral triangle ABC equals to BD plus DC. BD equals to 2 units and DC equals to 4 units. So BC equals to 6 units. So all the sides of triangle ABC equals to 6 units. So AB also equals to 6 units. And we know that AF equals to BF. So if AF is defined as X, if AF equals to X, then BF that equals to EF also will be equal to X. So we actually can write that AB equals to X plus X. Okay, AB equals to 2X, and we know that AB equals to 6 units. So we can write down that 2X equals to 6 because the size of AB is 6 units, and we will divide this equality by 2 and we will get that X equals to 3 units. Okay, so the value of BF is 3 units and the value of AF is also 3 units. Okay, and we defined FD as A and DC and DF as B, and we defined angle BFD as theta and angle BDF as alpha and angle EDC as gamma and angle CEB as beta. Okay, and we used the law of cosines in order to find out the value of A. According to the law of cosines, in this triangle, C square equals to A square plus B square minus 2 times AB cosinus theta. Okay, it is true for every triangle in the world. That is the relationship between the sides of any triangle in the world. Okay, that C square equals to A square plus B square minus 2 times AB cosinus of the angle that between A and B. Okay, so we actually implemented the law of cosines in triangle FBD. So we can say that FD square equals to BF square plus BD square minus 2 times BF times BD times cosinus 60 degrees. Okay, FD square equals to BF square plus DB square minus 2 times BF times BD times cosinus 60 degrees. And we have all the values of all the sides here. The only missing variable is FD. So it is one equation with one variable that is missing. FD is missing. So we put the data inside this equality and we found out that the value of FD or FD squared is 7. So FD, that is A, equals to the root of 7. Okay, and then we created equation number 1 that states that the sum of the angles in triangle BFD, this triangle, is equal to 180 degrees. This way we created our first equation, and we also created our second equation by the equality that the sum of the angles in triangle DEC also equals to 180 degrees. This is the second equation. And we added equation number 1 to equation number 2. We got this expression of equation number 3. And we created equation number 4 that states that the sum of the angles in the upper side of a straight line equals to 180 degrees in any point along a straight line or line segment. The sum of the angles on the upper side of the line segment of the line equals to 180 degrees. So we can say that alpha plus 90 degrees plus gamma equals to 180 degrees. Okay, so this way we created our fourth equation. This is our fourth equation, that alpha plus 90 degrees plus gamma equals to 180 degrees. And we got that alpha plus gamma equals to 90 degrees. So we substituted alpha plus gamma by 90 degrees in the third equation, and we got that theta plus beta equals to 180 degrees. Therefore, theta beta equals to 150 degrees minus theta. Okay, then we implemented the law of cosine of the law of sines in triangle BFD. Actually, the law of sines states that the following relationship exists between the sides and the angles of any triangle in the world, that A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay, so we implemented this law, the law of sines, in triangle BFD. In triangle BFD, we can say that FD over sinus 60 degrees equals to BD over sinus theta. Okay, according to the law of sines, FD over sinus 60 degrees equals to BD over sinus theta. Okay, so here we have the values of all the sides. So we got that sinus theta equals to the root of 3 over root of 7. From here, from sinus theta, we can derive the value of cosinus theta according to the trigonometric identity that states that sinus theta square plus cosinus theta square equals to 1. From this simple equality, we can derive the value of cosinus theta. Cosinus theta actually equals to the root of 1 minus sinus theta squared. Okay, actually we subtracted sinus theta squared from this equality, and then we took a root from this equality, and we got that cosinus theta equals to the root of 1 minus sinus theta squared. But we know that sinus theta equals to the root of 3 over root of 7. So if sinus theta equals to root of 3 over root of 7, then sinus theta squared will be equal to 3 over 7. So we substituted sinus theta squared by 3 over 7, and so we got that cosinus theta equals to the root of 1 minus 3 over 7. 1 minus 3 over 7 is 4 over 7, and the root of 4 is 2, so we can write that cosinus theta equals to 2 over root of 7, and we have already found that the value of sinus theta is the root of 3 over root of 7. Okay, in the next step, we have already found that beta equals to 150 degrees minus theta. If beta equals to 150 degrees minus theta, then sinus beta equals to sinus 150 degrees minus theta. Okay, and we have the second trigonometric identity that states that the value of sinus alpha minus beta equals to sinus alpha times cosinus beta minus sinus beta times cosinus alpha. So we can implement this trigonometric identity here in this expression in order to find out the value of sinus 150 degrees minus theta when alpha equals to 150 degrees and beta equals to theta. Okay, so we found out that the value of sinus 150 degrees minus theta, that is to say, it is actually also the value of sinus beta, is actually 1 over 7 over root of 7 times 5 over 2. Okay, but then we implemented the law of sines in triangle DEC, in this triangle, in order to find out the value of B. Actually, according to the law of sines, B over sinus 60 degrees equals to 4 over sinus beta, and we have already found that the value of sinus beta is 1 times 5 over root of 7 times 2. So the only missing variable here, B over sinus 60, equals to 4 over sinus beta, and we know that sinus beta equals to this expression. So the only missing variable here is B. So we put all the data here, and we found out that the value of B actually is 4 times root of 3 times root of 7 over 5 units, okay? But we know that the area of any triangle in the world equals to the base of the triangle times the height of the triangle over 2. So the area of the green triangle will be equal to B times A over 2. Okay? B times A over 2 is the area of the green triangle. We have already found, so the area is A equals to root of 7, and B is this expression, all divided by 2. Okay, so we found out that the area of the green triangle equals to 14 times root 3 over 5 square units. So in terms of numbers, we found out that the area of the green triangle equals to 4.85 square units. Okay, so the answer to the question is that the area of the green triangle equals to 4.85 square units. Okay, thank you very much.